There are so many places and things to explore in the universe, from distant exoplanets to faraway galaxies to my host intelligent life to massive black holes to bright stars. However, there is a problem with space exploration. Distance everywhere you want to go in deep space is far. For example, Elon Musk wants to put humans on Mars permanently while NASA wants to send astronauts there. However, any traveler going to Mars has to endure a grueling trip through harsh space that lasts not less than 5 months, even with the most powerful rocket in history. If only we could find a faster way to travel through space. Also, the next star to us is about 4.5 light years away, making it impossible to visit with the current space technologies. However, an accidental discovery promises to fix that problem by enabling faster than the speed of light travel. What is the discovery? How does it affect space travel, and how does it affect you personally? Join us as we explore how NASA scientists accidentally discovered the world's first warp bubble. Warp travel is not strange to fans of the Star Trek franchise. The warp drive is a charming futuristic technology from the Star Trek universe, which since its first episode in 1966 includes 10 television series and 13 feature films. In the series of movies, characters explore the universe using powerful and fast spaceships, traveling from planet to planet and communicating with a crew of aliens. The torsion engine is the center of attraction because without it the story would be implausible. The universe is strange, unimaginable, and insanely large, and even if you want to visit the next star, the immense cosmic distances create an almost impossible barrier. Let's take a look at the next star, Proxima Centauri, 4.5 light years away. This distance means it takes 4.5 years to reach the star. If you could manage to attain the speed of light, light flies at full cosmic speed and acts as a sort of universal speed cap, so any other method takes longer. In fact, if you decide to use the fastest space probe ever built, the long journey through the interstellar void would take nearly 8,000 years, so it makes sense to stay put to Earth and its immediate environment. Of course, the Star Trek crew didn't stay close to the Earth because they found a solution. This solution makes a long-distance travel possible by shortening the distance. The torsion engine using warp drive tech achieves this by juggling space and time, making for great entertainment. Warp drive was destined to remain imaginary until a scientist suddenly realized that such an engine was really possible. At the end of the last century, the physicist was Miguel Alcubierre, and he came up with a theory that rocked the scientific community globally. In 1994, Alcubierre watched an episode of Next Generation while doing his PhD research on Einstein's general theory of relativity, where heavy masses can curve space and time, and so Alcubierre picked up a scrap of paper, did the calculations, and laid the foundation for an article that appeared in the Science magazine later that year. In his paper, Alcubierre describes how you can compress space and time in front of a spacecraft and stretch it back behind the ship, so you have to travel a much smaller distance to the desired destination, safely trapped in what he calls a torsion bubble. In visualization, the concept was compared to a surfer riding a wave, and a metaphor often used to describe how a ship could travel the stars. There is, however, a problem with Alcubierre's warp bubble. You see, the warp engine is tough to build. In reality, you can't just curve space forcefully with normal mass. To do so, you need exotic matter which has negative gravity. Dozens of warp engine publications would follow in the following decades, but they all remained theoretical exercises and thought experiments that manipulated the formulations of the theory of relativity. In search of new insights, the need for the foreign matter remained. That was until Eric Lent, a physicist at the Pacific Northwest National Laboratory in the U.S., stepped in. He watched Star Trek as a kid. However, he has not been able to forget about the warp drive and has been thinking of how to bring the special machine to life. Lent's first read Alcubierre's professional article when he was a teenager, and while he found it fascinating, he didn't understand much about it at the time, but he continued to read warp drive publications long after he started working as a physicist. However, when he had some time to spare during the COVID lockdown months, he returned to his old interests. That was when he realized that everyone had overlooked something in his article. Alcubierre investigated the simplest possible solution to the formulations of the theory of relativity. This solution resulted in the Alcubierre engine, a warp bubble powered by a massive amount of negative gravity. Lenz decided to try some of the more unusual mathematics and realized he could also solve formulas with it. In the torsion bubble obtained by Lenz, the mass was in the places where the curvature was greatest, but much more importantly, you can make his bubble with ordinary everyday things. You didn't need an ounce of Stranger Things. Lenz was surprised that no one had tried this before. Although the Lenz engine was already more practical than the Alcubierre engine, you still needed a lot of mass for it, but it is still, because you need mass 1,000 times smaller than the sun. There's still a massive amount of kilos, but it is more manageable. It looks like warp bubbles could be put put to rest as a concept that could never happen in real life. However, a completely chance discovery is fueling interest in warp bubbles again and could prove to be a breakthrough. A research project funded by the Defense Advanced Research Projects Agency (DARPA) and NASA's Johnson Space Center may have accidentally discovered how to build a warp drive engine. Harold Sonny White, a NASA researcher at the Eagle Works Laboratory in Houston, Texas, published a research paper with his team in July about the possible structure of the energy density present in a Casimir cavity. According to the report, the Eagle Works team came across a micro-nanoscale system that predicts negative energy density distribution that closely matches requirements for the Alcubierre metric. In other words, White and his colleagues accidentally created a microscopic experiment while researching how energy distributes around wavelengths, a theory developed by Dutch physicist Hendrik Casimir. The experiment resulted in enough theoretical energy to achieve warp speed, a concept theorized by Alcubierre. In an interview, White explained that detailed numerical analysis of the team's custom Casimir cavities helped them identify a real manufacturable nanomicrostructure that is predicted to generate a negative vacuum energy density such that it would manifest a real nanoscale warp bubble, not an analog. Still the real thing, meaning